Okay, so this is the original tweet from someone named Andrew Webb, but we don't know Andrew. To count an animal population, if you can't catch them all, capture some. Mark them, release, and capture again. The ratio of new versus already seen tells you something about the total number. Shown here is an iterative mark and recapture with Bayesian updates to a belief about population size. Okay, so you can, first of all, just let's look at what he's doing in here and tell me what's different about what we saw Vincent doing.
Well, there's like different colors of fish. See on this first one, now there's this, and then the fish who get caught twice get moved from orange to green, so it counts how many times they get caught.
Okay. He's also doing it over and over again and continuing to tag the fish each time he catches a new batch, rather than just keeping just the same initial tagged fish. Just only those be tagged. Instead, he's moving toward where the entire population is tagged.
Okay, and so how is that helping him? Ignoring this side for a minute that I haven't explained to you yet. How do you think his process is helping him get a better estimate?
Well, I mean, he knows how many he's tagged, so he can do tagged versus the entire, or tagged versus total, and he can get an estimate for the population size.
Okay.
I mean, he can do that. This is kind of the equivalent to doing multiple trials of just one tagging, because he still knows how many he tagged initially but he doesn't know the total population. So when he recatches a bunch, he can do tagged versus total to get an estimate for how big the population is each time.
Okay, so what do you think?
Well, I don't think you would need to keep tagging them again. I think you could sort of keep going on, like just tagging 50, and then I think then you could just run multiple trials and then collect the average from that.
Okay.
Maybe.
Yeah, it's tricky because like what you'd really love to do is do like 10,000 trials.
Yep. You can't.
Yeah,
really
that's hard to do. So you have to find ways to try to improve. And so I'm going to wait till this restarts in the beginning. So in the beginning, what you'll see is a flat distribution, and that's just saying I don't know how many fish are in the pond at all. It could be any number. And then once he gets a single estimate, so here's any number. Once he gets a single estimate on recapture, then he can say, hey, you know what, the distribution maybe looks like this. Maybe here's my actual amount, I don't know, but I think there's that many. And then each one he catches allows him to draw a distribution of what he thinks the number of fish in the pond are. Yeah. And notice how what happens to this distribution with more samples.
So
it's less clustered in. It's like, it's less spread out.
It sort of centers around where all the data points toward population size being. And with like 2 or 3, it's not that great, but as you get more captures, you can get a better estimate. You can see it's not exact, but it's pretty close.
Yeah, do you think you would ever be able to say exactly how many fish were in the pond with your sampling?
No, you only really, even here you don't really say exactly, you kind of get a range, like here you think maybe it's like 200 to 500 or something, and then now it's like 250 to 450, and the range just shrinks until you can kind of see about where your population is.
Okay. Yeah. All right, so cool. So I'm going to show you what I'm doing now for our simulation, and then we'll run a few simulations and see what we find.
Okay.